Hello friends. We are back with our new video. In this video, I will discuss how to create a normal qqplot in RnorM Studio using ggplot2 that you can use for your official presentation or in your publication. Please visit our website StatswithR.com for more details. And if you have any queries, shoot us an email at learnstatisticwithr@gmail.com. The overall process involves some steps, and I will discuss every step, so that you can change some of them, according to your requirements. Let's begin. First, I just give you a brief overview of what a normal qqplot is. Suppose you have some observations x1 through xn, and you want to check whether a normal distribution fits your data well or not. The first step of a normal qqplot is fitting a normal distribution to your data, and estimating the mean and variance parameters. Next, you calculate low through high data quantiles and also the corresponding quantiles of the fitted normal distribution. Then you plot the quantiles of the normal distribution along the x-axis and call it theoretical quantiles. And plot the corresponding data quantiles along the y-axis and call it sample quantiles. Here you try to see whether the two types of quantiles are close to each other or not. If they are close, you might say that a normal distribution fits your data well. A very important thing is to note that the terms mu hat and sigma square hat are random quantities. And so, each theoretical quantile is a random quantity. First, here we see a normal qqplot that we can create using the functions qqnorm and qqline from the package stats. Note that the x-axis denotes the quantiles of a standard normal distribution but not of the fitted normal distribution. Most of us are more familiar to this type of qqplots, but today, I will discuss how to create a qqplot using ggplot2. Let's start. Here, I assume that you know how to load your data into RnorM Studio. Suppose you have a numeric vector of observations and you store it in a variable, say, x. If you haven't installed the package ggplot2, install it from CRAN using the command install.packages. Once you have installed, call it using the command library ggplot2. You need another package qqplotr, install it, and call it into R using the function library. Now, you are ready to create your normal qqplot. In the console window, type ggplot, mapping equals to AES, sample equals to x, plus stat qqpoint, within brackets, size equals to 2. The default size in the function stat qqpoint is 1.5, so if you are happy with that, you don't need to mention anything, just leave a blank bracket. Now, press enter. Okay, you get your first normal qqplot using ggplot2. The first thing is the axis labels are not clearly written and you might want to write them properly. So, add xlab, theoretical quantiles within quotes, plus ylab, sample quantiles within quotes. Now, press enter. Okay, you get your second normal qqplot. In general, we always add a reference line to the qqplot, that is, the straight line y equals x. This helps us to understand how much the data quantiles deviate from the theoretical quantiles. To do that, add stat qqline, a blank bracket. Now, press enter. Okay, you get your third normal qqplot, using ggplot2. We see that some quantiles, particularly at the tails, deviate from the line y equals x. You might feel that a normal distribution is not a good model for this data. So, let's get deeper. Note that, the theoretical quantiles are functions of the estimated mean and standard deviation of the data. Thus, the theoretical quantiles are random quantities. If you change the data, they will also change. So, it is always a good idea to draw point-wise 95% confidence intervals along with the line y equals x. To do that, add stat qq band, a blank bracket. Note that, here the ordering matters and you should specify the command, stat qq band, before stat qq point and stat qq line. Now, press enter. Okay, you get your fourth normal qqplot, using ggplot2. You see that despite some points being far from the reference line, they are within the confidence band in general. So far, we are mainly done with the qqplot for your personal use. Now, let's add some more things to make it a publication or a presentation quality one. These steps are similar to other ggplots that we have already discussed in our channel. Now, suppose you want to add some description of the data in the title. Say, you are working with a dataset of heights and you want to add normal qqplot of heights. To do that, add the line ggtitle, within brackets normal qqplot of heights. Now, press enter. Okay, you get your fifth normal qqplot. You can see the title is printed now. Now, you might want to move the title to the center. To do that, add a line. Theme, plot.title, equals to, element underscore text, just, equals to, 0.5. Okay, now press enter. And you get your sixth normal qqplot. You can see the title is at the center now. Now, you may feel that the fonts of the title, the axis labels all are very small and you want to enlarge them. To do that, add a line. Theme, axis.text equals element underscore text, size equals 20, this increases the font of the axes. Axis.title equals element underscore text, size equals 20, this increases the font of the axis titles. Plot.title equals element underscore text, size equals 20, this increases the font of the plot title. If you don't want one or two of them, you can remove that line. The larger the size you want, you need to fix a larger number. So, choose a number accordingly. Okay, so finally you get a normal qqplot using ggplot2, that you can probably consider to use in your presentation or in your publication. If you see that your dataset shows evidence of heavier tails than a normal distribution, you might need to fit a student's t distribution, and to judge the fitting, you need a student's t qqplot. To do that using ggplot2, watch our video how to create a student's t qqplot in R, using ggplot2. If you found this video helpful, please like, comment, share and subscribe to my channel. And press on the bell icon for more updates.